Question 8b, part 1. Since the tangent to the curve at the point x equals a is parallel to the line, we know that the gradient of the curve at x equals a is going to be equal to the gradient of the line 4y plus 3x equals 0. In the previous part, we found that dy dx was ln x minus 1 over ln x squared. So what we're going to do now is we're going to substitute x equals a into that so that we can work out what dy dx, or the gradient of the curve c, is at that point. So subbing in x equals a into this, what we get is that dy dx equals ln a minus 1 over ln a all squared. Looking back now at the line 4y plus 3x equals 0, we're going to rearrange that to find the gradient of that line, and rearranging gives us that y is minus 3/4 x, which tells us that the gradient is going to be minus 3/4. Since the line is parallel to the curve, the gradient is going to be the same, so I can now write an expression saying that ln a minus 1 over ln a squared equals minus 3/4. What we want to do now is we want to try and rearrange this into a nicer form so that it looks a little bit more like the quadratic that we're trying to show. So first thing we're going to do is going to multiply both sides by ln a all squared so that we have a slightly nice looking expression. So first of all, that gives us ln a minus 1 equals minus 3/4 and then ln a all squared. And then the next thing to do is to multiply both sides by 4 to get rid of the 4 from the bottom of the right hand side. So I've now got 4 ln a minus 4 equals minus 3 ln a all squared. Now looking back at the question told us that u is ln a, which means that ln a all squared is going to be u squared. So if I substitute these bits of information into the question, or into the equation, I end up with 4u minus 4 equals minus 3u squared. And then rearranging, we end up with 3u squared plus 4u minus 4 equals 0, which is what we were trying to show.